Hi, it's Wednesday, November 26th, and we're just about now to the end of the 2025 Atlantic hurricane season. The season officially runs through November 30th, and so by this upcoming Sunday, the season will be ending. So what I want to do now is take a look back over the past several months and see how the seasonal activity compares to the seasonal forecast that I made back in May and June. And so first things first, I want to give a little bit of background on what we were looking at prior to the hurricane season beginning. What I'm going to show you is a North American model ensemble, which is one of our climate models that helps us forecast at the seasonal range. And we're showing you the forecast from May, so before the hurricane season had begun on June the 1st. And this is showing you the seasonal temperature anomalies across the world, averaged out across the 3 months of August, September, and October of this year. And we look at this so much for hurricane season forecasting because the oceans can tell you a lot about what the weather is going to do, not only in hurricane seasons, but across all seasons across the globe. But specifically for hurricane seasons, if you look across the tropical latitudes of the world, you'll see that these primarily are consisting of water. This is important because patterns that form in the oceans tend to last longer than they do in the atmosphere. And so patterns that form in the oceans in late spring, for example, will tend to last into the summer and fall months into the peak of hurricane season. So you can use this as a good benchmark to make an educated guess of the hurricane season activity you might see going through the rest of the year. Now, in this specific instance, we're talking solely about the Atlantic hurricane season, and there's three primary factors we can look at to determine if the season is going to be above average or below average. And the first one, and likely most prominent one that everybody knows, is ENSO, or El Nino Southern Oscillation, which is a zone across the equatorial Pacific that we monitor every single year. This is a huge impact on weather across the globe, but specifically for hurricane seasons, this is typically a big slam dunk decision maker on is it going to be above average or below average in the Atlantic basin. And the reason for that is because this is such a large body of water and it oscillates every so often. So sometimes you get warmer water than normal across the equator, so that's an El Nino, and that enhances the Pacific hurricane seasons. And because of all that anomalous convective or thunderstorm activity in the Pacific, you increase wind shear across the Atlantic. And as a result of that, it's harder to get hurricane activity, and that leads to weaker hurricane seasons as a result. On the flip side of that, we've got a La Nina, which is the opposite, having cold water form along the equatorial Pacific. That suppresses a lot of the thunderstorm activity in the Pacific and in turn suppresses the hurricane seasons in the eastern and central Pacific. And because you have less convection, you decrease the amount of wind shear across the Atlantic and you allow room for a more active Atlantic hurricane season. And so that's why we look at this so much, because this is typically your one indicator. Is it going to be above average or below average in most cases? Now, this year was a bit interesting because compared to the past few years, we haven't really had a well-defined signal of an El Nino nor La Nina taking place as we head into the peak hurricane season. You can see on this map, specifically from the NNME, we have a cold bias neutral taking place. This is not an overwhelming signal of a La Nina taking place, and this is one of the colder ensembles that we had. I'll show you the European in just a moment to compare. That one was much warmer, so the general mean across all climate models was an ENSO neutral signal, not really El Nino nor La Nina. This is important because if you don't have the overwhelming signal of ENSO, you'll have to look at other oceanic patterns because those can start to take hold and have a more significant impact on the hurricane seasons further north. And the other thing we can look at across the Pacific is further north, the negative PDO, or the Pacific Decadal Oscillation is the full name of that. And we've been in a negative state of the PDO for just about 6 years now, and it'll probably be negative for a few more years. We'll probably see it flip in the late 2020s, but you can tell it's negative because we have warmer than normal anomalies sitting off the east coast of Japan and cooler anomalies relative to that off the west coast of North America. And generally, this is a good sign for the Atlantic hurricane season because, similar to a La Nina, this can help to suppress hurricane season activity in the Pacific basins as you have cooler water typically running down into the tropical latitudes. And so this is generally a good sign for the Atlantic hurricane season. Now, one thing that was not a good sign was the third area that we look, which is the Atlantic itself. And if you go back a couple of years back to 2023, we had a very favorable look in the Atlantic basin. We had very warm water kept down to the tropical latitudes, classic positive AMO look. But this year, it's a little bit different. Since 2023, we've seen the warmth be moved into the subtropical latitudes. And you can see on this map specifically, the warmest anomalies are kept into the subtropics, with the Azores, Bermuda, and off the US East Coast. And this is so important because this can disrupt the normal Hadley cell in peak season. And if you don't know, the Hadley cell is where you have rising air in the tropical latitudes. And what happens is all that rising air moves north and it sinks into the subtropical latitudes. And that allows an effective convective process and allows the rising air to be focused where tropical development is most efficient at the tropical latitudes. But if you get warmer water like this instance in the Atlantic, this can start to disrupt that because in the western part of the basin, especially, you have warmer water because the Gulf Stream does bring warmer water further up north. And you also have a more favorable larger ocean current across the Atlantic basin. And so when you have warmer anomalies there, you enhance that area that is typically not so enhanced by warmer anomalies. And so with that warmer water, you get more convection, and that can start to disrupt the Hadley cell where you get rising air in the subtropics and sinking air in the tropical latitudes. And you can get hurricanes, of course, in the subtropical latitudes, but it's not where it's most efficient. The most efficient zone is in the tropical latitudes where tropical waves are coming off of the west coast of Africa. And we saw a lot of times this year where tropical waves have come off and it looked like they had a chance to form, but they never did. And they really just struggled with dry air issues because of that disrupted Hadley cell configuration. And so putting all of these factors together, it's really just left us with a lot of questions, and that was really the main story for the hurricane season forecast. We were very uncertain on what the hurricane season was exactly going to do. It was not a slam dunk, it's going to be above average. It's not a slam dunk, it's going to be below average. And one thing that we can further look at to signify this is these two regions that I've just marked in the red boxes, the Nino 3.4 region and the AMM or Atlantic Meridional Mode. The Nino 3.4 region is this box in the Central Pacific that we monitor and is typically used to determine if you have an El Nino or a La Nina. And the AMM, Atlantic Meridional Mode, is this water off the west coast of Africa, and this is basically telling you what the water is like in the tropical latitude. So if it's warm, that's a good sign. If it's cold, that's a bad sign. And one thing that we were uncertain of, even more so than the three factors that I just mentioned, was where were these going to go in the peak of hurricane season? How were they going to modulate as we go throughout the summer and into the fall months? For example, I mentioned that the NNME was one of the coldest solutions in the equatorial Pacific. If we compare it directly to the European model back same month, May forecast, this was warmer, showing a warm neutral flirting with the El Nino threshold in the peak months of hurricane season. And we saw similar trends in the AMM area as well. Some models had shown warmth returning to the tropical latitudes in the Atlantic, where some showed it like the NNME being colder and not as favorable. And so to highlight exactly how much uncertainty this gives us, we can make a graph with a direct comparison of these two regions. So what we're going to do is take the AMM and subtract the anomalies in that box from Nino 3.4. So the difference between those two regions is on the y-axis of this graph. And on the x-axis, we're comparing that to Atlantic ACE, which is basically a measure of hurricane season activity. So the further right it is on the map, the more active the hurricane season. And this is also color-coded to tell you the state of both of these areas across those two boxes. So for example, the red dots are when Nino 3.4 is cold and the AMM is warm. That's generally a favorable configuration for the Atlantic, and you typically, as a result, see more active Atlantic hurricane seasons take place. While on the flip side, a blue dot tells you that Nino 3.4 is warm and the AMM is cold. Generally bad, so you typically have less active hurricane seasons there in the blue dots. But how about in years when these could be equal, when both are warm or both are cold? For those, you want to focus on the yellow and the purple dots in this. And this really does a good job of illustrating the uncertainty that we had back in spring for the hurricane season activity. You can see we have some years like 1983, 1987, 1973 that were very inactive hurricane seasons, all things considered. And we have other years like 1996, 1969, 2003, 2004. Those were very active hurricane seasons. And those were in cases where both Nino 3.4 and the AMM were warm or cold. And generally, what I've seen a lot of people do in their forecast is take a middle ground approach. And I've done a similar thing in the May and June forecast that I made. And if you take the middle ground of this general range, you get a near to above average season. And I leaned into near to above because of the negative PDO, as that is still a favorable sign for the Atlantic. So odds likely favored it to still end up above average. And so, how did this actually go? How did the hurricane season actually perform? Well, the hurricane season did end up above average. And you can see all my forecasts here, May and June, and the actual numbers there with them color coded to the difference compared to climatology. And you can see there are some mixed signals on the exact activity that we saw. We did not quite reach the amount of tropical storms and hurricanes that you typically see in an average hurricane season, but we had more major hurricanes and more accumulated cyclone energy, which is again a measure of hurricane season activity as a whole. And so that means that the season overall was above average. And comparatively to the forecast that I made, generally the ranges were decent. They did fall short in hurricanes and tropical storms, especially in the June forecast. But the major hurricane in the ACE forecast, those actual numbers fell comfortably within range. And so I felt good on the forecast that I made back in May and June. And of course, there's some stuff we can improve on going further into the future for next hurricane season, and those will certainly be looked at. But generally, I'd say these forecasts did pan out very well. And for NOAA classifications as well, you might be wondering what their official classification of an above average hurricane season is. That's where accumulated cyclone energy is 126% of normal. And luckily, the climatological average is 100. So simply 126 units, that's above average if it's greater than that. And we got 132.5. So by NOAA's threshold, this has been an above average hurricane season. And you can also see on the far right, and we'll talk about this in a little bit, the analog average, you can see those were a little bit higher. We'll talk about the analogs in just a moment because I did have a new hunting method to try and find the best methods for this hurricane season. And this is all the tracks that we had in this hurricane season. And one thing that we'll talk about as well with the analogs that I had is the track density that we had this hurricane season. You can see a lot of these storms were focused into the subtropical latitudes, and that's one thing I highlighted in my forecast back in May, especially when I dove deep into all the research that I had done for my seasonal forecast. The one real exception to that is Hurricane Melissa, which happened in the Caribbean and became a powerful Category 5 there late last month. Now, what we're going to do is we're going to go and look at some verification stuff. So first of all, how did the oceanic patterns actually verify comparatively to the forecasts that we saw on climate models? And you saw at the beginning with the NNME, it showed a cold bias neutral taking shape. That did happen. We have a cold bias neutral now. And in fact, this month it did flip to La Nina. I believe it was either October or November. It flipped into a weak La Nina territory. So the NNME was on the right side of that forecast. The European was a little bit too warm. One thing that was also clear is a negative PDO was correct. And this was a very strong negative PDO, especially in September. And that played a huge role into suppressing some typhoon activity, especially in the Western Pacific in the months of September and even surrounding months of August, September, October through the peak months. And you can see the Atlantic is still in this not so optimal configuration. It doesn't exactly match what we were seeing in the NNME forecast, but you can see the warmth is not solely kept to the tropical latitudes. It's kind of all over the place, and we have this band of warmer water across the subtropical region. So generally, oceanic pattern-wise, this did verify nicely. And if we look closer at the ENSO regions, you can see that this is across the past 10 years, but we're focusing on the red area, which is 2025. You'll see that we generally floated around in the cold bias neutral area. And we really didn't get near that El Nino threshold like the European model had suggested. And I think in June and July, the European model did back off on that when it became apparent that we weren't going to an El Nino going into peak of hurricane season. And you can see just at the end there, as we get into October and November, we have now dipped down into La Nina territory. And that could have some implications on next hurricane season, but we'll talk about that when we get there. Okay. Now we're going to talk about the analogs that I had chosen. So 2024, I made a forecast for 2024, several of them, and I had what I think is decent analog hunting method, but it's very vanilla. It was just looking at oceanic patterns and comparing them subjectively to past hurricane seasons. And I felt like there was a little bit of a bias that could take place there. when choosing all of those analogs. So I made it my mission this year to choose a new method and compare these years objectively. And through this process, I got 6 analog years that resulted in a map like this. And this is a track density map that was expected for this hurricane season. And you can see that this was generally correct. And we'll compare this to the 25 tracks in just a moment. But you can see the general expectation was for most tracks of hurricanes to be in the Western Atlantic. The only really part where it failed was in the Western Caribbean, though Melissa did happen there. So if you want to count that, you can. And so my method was to, instead of just solely looking at the oceanic patterns across the world, take a look at as well across the winter pattern across North America, specifically the end of winter pattern in February and March. And I know this map is disgusting. It is very messy. Basically, what you're looking at is the shaded regions are geopotential height anomalies. So red is more high pressure than normal, blue is more low pressure than normal. The black lines are sea level pressure anomalies, and the blue dotted lines are sea surface temperature anomalies. And what I wanted to show here, this is 2025's end of winter pattern. And what I wanted to look for is years that had a similar end of winter pattern like this, because the winter over the US, it may not seem like it at first, but it can have a significant impact on the hurricane season down the road. For example, you can see that we have this red blob extending into the Western Atlantic and Central Atlantic, characterized by a cold bias neutral that we had across the winter last year. And what can happen with this is with this higher pressure in place across that region, it can enhance the normal trade winds across the tropical regions. And that can help to cool off the waters in the tropical latitudes and help result in that non-optimal look that we saw in the model forecast from the NNME. And so I objectively compared these. I didn't do it subjectively. I compared it via code. And so these were the most objectively correct years, or objectively similar years to 2025. And we got 6 years. And what I did was I compared the closest years to the end of winter pattern to the closest years to the overall global oceanic pattern. And the intersection between those two were the closest analogs for this hurricane season. You can see the 6 years that we got here: 2017, 1984, 1996, 1979, 2008, and 2011. And this is how the end of winter pattern showed up on these years. And generally, there are some similarities to pick out here. You can see that general higher pressure that is trying to nose in across the southern tier of the United States. And we have some cooler anomalies, it looks like, off the west coast of Africa. Hard to tell if that's negative or positive on that. But generally, these seem like a good match comparatively to the oceanic pattern and the end of winter pattern overall for this hurricane season. And so what we could do beyond that point is compare how the forecasts were for the oceanic pattern across the globe. And you can see in this map on the right, that's the analog years, average sea surface temperature anomalies through peak seasons, August, September, and October. And you can see it generally had things right. The negative ENSO signature, cold bias neutral, not really La Nina, and the negative PDO signature across the Northern Pacific. And we also had, a less than optimal configuration in the Atlantic. I think there is a little bit of bias from some years getting to a warmer, more favorable configuration in the Atlantic. As you can see, we do have some of that warmth in the tropical latitudes, and we'll see this especially when we go into the difference between the right and left maps. And the left map is just this year's observed August, September, October anomalies. And so what we can do is directly subtract these. So we're going to subtract the anomaly map on the right from the observed ones. And this is the difference. And immediately the thing that pops out is the PDO. And that was naturally going to be colder on the anomalies because the PDO is very negative right now. And it has been in a very strong negative state, one of the strongest that we've seen. So naturally that's going to be a bit of a eye catcher on these anomalies, but primarily pay attention to ENSO and the Atlantic configuration. ENSO, we can see it was a little bit too warm on these anomalies, especially in the eastern part south of the Eastern Pacific Basin. But in the Atlantic, you can also see that sign of more active hurricane seasons sort of skewing the data set there. You can see we have this bias towards a more positive AMO look along the eastern part of the basin. And you saw earlier in the analog averages that they were higher than climatological averages, and we did have a wide range in these in these analogs for the exact hurricane season activity that we would have seen. And you can also see it was much colder than the actual observed anomalies in the Western Atlantic, the Gulf of Mexico, and the Caribbean. Now, one thing where this did go well was the track density forecast. And you can see now this is that same map that I showed you earlier compared directly to the 2025 hurricane tracks. And this generally verified very well. You can see exactly where the analogs expected the most frequent hurricane activity track was generally matched by the hurricanes that we had this hurricane seasons. And so this leaves a bit of mixed signals of, is this a good method to continue on to in future years? And I think, yes, I think there is, some things that need to be fixed clearly with this kind of a configuration that we see taking shape in the anomaly differences. And I think it can be improved going into future years, but I think this is a good way to take out some of the subjective bias of selecting analogs and get the best picture of what a hurricane season can do. And I certainly will be continuing this into 2026 once we get around the time to talk about forecasts for the 2026 Atlantic hurricane season. But that's another story for another day, and that is all for my verification discussion today. I'll have more regular videos starting probably after Thanksgiving. It is Thanksgiving in the US, so it's a little bit busy, so probably won't have too much going on here, but we'll talk about the tropics again, or current tropics, that is, in a little bit, as we have a couple of systems that we may have to watch, especially in the Western Pacific, going for the next few weeks. Thanks for watching my presentation, and that's all. Have a good Thanksgiving if you're in the US.